As of late July 2025, there has been no official announcement confirming the signing of the J-10C procurement agreement between Iran and China. However, diplomatic signals, media leaks, and regional intelligence reports consistently indicate that behind-the-scenes discussions are ongoing. Iran's urgency stems from the stagnation of its current air force capabilities. Its inventory, based mostly on legacy aircraft from the 1970s and 1980s, faces obsolescence in radar survivability, combat range, and weapons effectiveness. Iran recognizes that even a limited introduction of a 4.5-generation multirole fighter like the J-10C could provide a measurable boost in its deterrence posture, especially in contested airspaces. From the Chinese perspective, the situation is nuanced. China has demonstrated increasing openness to military exports in recent years, including unmanned systems, naval platforms, and select aircraft. However, its aircraft exports remain highly selective. Unlike drones or wheeled armored vehicles, combat jets involve high-end technology that could have strategic consequences far beyond the seller and buyer. Once sold, a modern fighter platform has a life cycle of 30 to 40 years, during which time its software, weapons, and data links can evolve or become vulnerable to misuse, reverse engineering, or leakage. This makes China's vetting process cautious, particularly regarding countries that face long-standing sanctions, military embargoes, or domestic instability. Even if the aircraft being exported is a downgraded variant, like the J-10CE, there are still controls in place on how much onboard computing power, radar integration, electronic warfare capability, and missile interface will be included. Beijing's caution is especially evident in the way it handles avionics encryption, engine control modules, and long-range missile fire control software. In the context of the Iran deal, this means any J-10C delivered would likely be stripped of the most sensitive or high-end export-restricted technologies. One often overlooked hurdle is the integration of the J-10C into Iran's current command and control ecosystem. Iran's Air Force infrastructure is built around older Soviet and U.S. origin frameworks. The networked systems, ground-based radar stations, electronic warfare units, and mission planning software are not compatible by default with Chinese architectures. This means extensive software bridging, interface engineering, and possible hardware retrofitting are required to allow the J-10C to communicate with existing airspace surveillance and air defense command layers. Even the aircraft's datalink system, essential for secure team combat, real-time radar sharing, and over-the-horizon targeting, would need to be modified or adapted to fit Iranian operational procedures. Iran also lacks existing deep logistics support for Chinese aircraft. Every combat jet type comes with a long list of required support infrastructure, toolkits, power units, calibration equipment, radar tuning labs, software diagnostic interfaces, and weapons loading gear. Since Iran has never previously operated Chinese fighter aircraft, it does not possess these back-end systems. Creating them from scratch is costly, slow, and vulnerable to disruptions, especially in a sanctions environment where importing dual-use equipment may attract international scrutiny. Additionally, supply chain vulnerability remains a major concern. Even if the initial aircraft are delivered successfully, Iran must secure a long-term supply agreement for spare parts, engine components, software updates, and possibly satellite data required for modern combat operations. If that supply chain is ever delayed, restricted, or politically interrupted, the entire fleet could be grounded. This risk factor grows if the aircraft cannot be fully indigenized, a process that would require licensed production or at least partial technology transfer, something China has been very reluctant to allow in previous defense contracts. The financial structure of the deal also remains complex. Iran is not expected to pay the full amount in hard currency. Instead, ongoing reports suggest that the deal could be partly financed through discounted oil deliveries, future infrastructure cooperation, or long-term deferred payment arrangements. However, such structures are risky from the seller's perspective. They require long-term political confidence and guarantees that payments will continue, even amid future sanctions cycles or leadership changes. Some sources have suggested that Iran may offer to co-develop certain subcomponents, like training simulators or auxiliary ground systems, to lower costs, but there is no official confirmation of such arrangements. On the technical side, there are still questions about the battlefield survivability of the J-10C in environments featuring high-end electronic warfare, stealth aircraft, or active jamming. While the jet has an AESA radar and access to advanced missiles, its lack of stealth shaping and single-engine design limit its survivability against fifth-generation aircraft. In a networked air battle, especially where satellite-guided munitions and airborne early warning aircraft are used. The J-10C's performance may be constrained. Iran would need to build not just a J-10C fleet, but also supporting assets like electronic warfare jammers, AEW&C platforms, aerial refueling aircraft, and satellite communications to truly unlock the jet's potential. Moreover, the training pipeline remains underdeveloped. Converting experienced pilots from older jets like the MiG-29 or F-4 to the J-10C is not an easy transition. These jets differ in engine behavior, fly-by-wire sensitivity, radar interface, HUD symbology, and even G-tolerance profiles. Training must therefore be done using dedicated two-seat variants, supported by Chinese instructors, or simulators built specifically for the variant being delivered. As of now, there are no publicly confirmed contracts for a Chinese-built J-10C simulator system inside Iran. Without that, in-air training becomes the only option, expensive, time-consuming, and operationally limited. In the regional context, neighboring air forces have continued to modernize. While the acquisition of a J-10C fleet would narrow some gaps, Iran would still remain behind in areas like multirole flexibility, electronic warfare readiness, and air-to-ground precision strike unless additional platforms or systems are acquired in parallel. Even if the deal is finalized by end 2025, the time needed for delivery, training, operational testing, and combat readiness will delay meaningful impact until 2028 or beyond. While Iran is actively pursuing the J-10C to modernize its fighter fleet and strengthen its airpower posture, the path forward remains complex and heavily delayed by real-world constraints. Each obstacle, be it financial, logistical, technical, or diplomatic, requires not only bilateral negotiation but long-term, sustained execution. Even after the delivery, the operationalization of the aircraft will take years. Only then can the full capability of the J-10C be assessed in a realistic combat environment. The outcome of this deal, therefore, is not just about a purchase, it is a test of Iran's ability to re-enter high-performance air combat under the constraints of global isolation and shifting geopolitical balances.